record. Recording in progress, guys. Let's start. Okay. So in this book right here, guys, you see, there's a very big QR code again. So this QR code right here, it's the answer plus some additional material. Because right here, this book only got Form 4 Chapter 6, which is your acid, base, and salt. And the salt, the notes here is only on salt actually. So that's why you need to be actually very what do we say? You need to actually use the QR code for the rest of the notes and exercise, okay? Because we don't want to send you too much stuff right later, or you say, oh, your teacher so thick, I don't want to do. So we give you like in a PDF version so got answer here and then got additional material. So on this seminar right here, we're gonna actually focus more on the salt topic because most likely you all already forgot what you all learned in Form 4 and then you know Catholic okay, Jared from Catholic Catholic is the crazy school that actually have to include for the whole Form 4 for your next exam. Okay, so okay, nice lah. This chapter I never study. Okay. Okay, others got okay. Wait let me do some announcement first because some teacher never do seminar, never tell me. Yeah. Okay, I'm back. Okay, okay, so guys, let's start. Okay, so on this case, you see, okay, this book here, we're gonna actually straight away go into salt, because this before salt, right, we're supposed to have like acid and base. Okay, so acid base there in front got like those neutralization, got some calculation for the pH value. Remember, we have neutralization formula, we have the pH value formula, and then we have like dilution formula kind of. So we have multiple topics of your acid bases. Then only we go for salt. Okay, but then today we mainly focus on salt because acid base that one can do self-revision again. Salt is the one that is very hard, and then you always give out one. Okay, so for here, we're gonna actually have a solubility of salt so they actually in salt, like there are multiple topics that you're gonna actually like at least know the big picture about what actually is inside your salt. Okay, so you see we got solubility of salt, and then you see you scroll a bit, you see got solubility of salt. Okay, and then okay, then you see like salt preparation, got method 1, okay, and then method 2, okay, and then method 3, okay. So got 3 ways of salt preparation. Then after that got what? Got your color of salt, okay, and then got what? After color, we got the effect of heating, and the last 2 topic is your tests. So your gas test, anion test, cation test. So all the tests to actually see the color change, this and that. Okay. So you see, got anion test and then got cation test. Okay. So but then you see cation test also got test 1, also got test 2. Okay. So there's a lot of tests that you have to actually know the procedure and then you know the observation. That's why it's hard right now. This chapter, just the salt part is already very hard. So let's try to focus on today on all these parts okay. Wait, okay. Wait, normal notes, this is 3 books, right? If not mistaken, salt is around, minimum 3 books. Got part 1, got part 2, got part 3. Okay, but I forgot whether got part 4 or not. I think part 3 and I think 3 parts. Okay, so right here we are actually looking into okay, I will just glance. Okay, guys, I will just glance through. Okay, I'm not gonna go in detail. Because you go in detail, not enough time for today. Only got 2 hours. So the first part is about solubility. So what salt is confirmed soluble in water? We call this the spun salt. Okay. So spun salt actually, whenever you see SPAN, these 4 confirmed soluble in water. Then you see, if you see like chloride, you see that it's all soluble except persatuan, agama Hindu. Remember this? So you see, usually I ask you all to memorize in this way. So if you remember like CL, CL is roti canai. So roti canai, the canai links you to Persatuan Agama Hindu. Then the SO4 is siu bao, siu yok, okay, which is pork. Pork link you to what? To what race? Chinese. You see, Persatuan Bahasa Cina. In this way. So we try to memorize like when Cl minus will become insoluble, when will SO4 2 minus become insoluble. So in this case here, so Cl minus SO4 2 minus usually is soluble, except when they combine with these three and the other three. So make sure you check later on to whether you know like your salt is it soluble or insoluble. You have to check whether your chloride pair with who. Then your sulfate will pair with who. Okay, so these are quite important. Okay, then after that we have like carbonate, oxide, and hydroxide. All these three confirm insoluble, but because you see your SPN, okay, you can actually accept spa. Means if I take the top one and the bottom one mixed together, I will follow the top one because the top one is actually like the priority, okay, the main priority. Okay, so on this case here, so we have SPN, and then we got like the confirm soluble, confirm insoluble, and then Cl minus and SO4 minus is sometimes insoluble, but majority of the time is soluble. Okay, so these are some practice you guys can do yourself. You put a tick and or cross, okay, to see whether is it soluble or insoluble or not. So that's why on this case, this one just leave it. I'm going to do this just for yourself, self known. So when you go down, okay, you see like solubility of salt also linked to what? Also linked to your salt preparation. Okay, because the reason why we want to learn solubility of salt, why I need to know like what salt soluble, what salt insoluble, is actually to link you to your salt preparation. Because soluble salt got soluble salt method, then insoluble salt got insoluble salt method. Correct. So that's why you see, and here, wait, let me close my door. To avoid my cat from going out. Okay, so you see, your soluble salt and then your insoluble salt. So soluble salt, you see, like what? Because soluble salt also got two methods. So one is actually your ammonium salt, sodium salt, potassium salt, where we're going to use neutralization method. Then if it's like non-ammonium, non-sodium, non-potassium, usually we actually use the reaction between acid plus metal, acid plus metal oxide, acid plus metal carbonate. Okay. So means you see, soluble salt also separate into two different methods just to prepare soluble salt, but different category lah. So the category usually I will say this is considered spa salt. This is like non-spa salt. So the spa stands for sodium, potassium, ammonium. Okay. So if you see a salt it's soluble and then got spa inside. Okay. A spa means any one of it lah. Whether got sodium, potassium, or ammonium, then you see, right? You can actually have this first method. Then if you're trying to produce a salt that is soluble but non-spa, non-spa means that you're gonna use the second method. Then if you want to produce insoluble salt, then you're gonna go for the last method, the double decomposition reaction. Okay, so that's why you see, guys, this is like a big picture about what happened when you actually want to prepare different type of salt. You're gonna use this according to this category lah. Okay. So you see, if it's neutralization, acid plus alkaline. Okay. If it's like non-spa, no specific name, no reaction name, no method name, just say reaction between acid metal oxide, acid metal carbonate. Okay. But then to produce insoluble, got method name and reaction name. The reaction name is called double decomposition reaction. The method name is called precipitation reaction. Okay. So that's why from here, on what we actually see from here, we're gonna actually use these three methods in details. So the details is here. So see, if you want to prepare spa salt, okay, method one, you want to produce a soluble salt that contains spa. It depends on what salt you want to produce. You see the sample is here. What if I want you to produce NaCl? Then I need to remember NaCl is a spa salt. Then spa salt must use neutralization reaction. So neutralization reaction keyword is what? Is acid plus alkaline, correct? So you must think about an acid that can actually give you Cl, and then think about an alkaline that can give you Na. That's why only you can actually form NaCl. So you see, my answer here is I'm going to use hydrochloric acid and sodium hydroxide just to form NaCl. Because if you think about it, what if I use like other acid and other alkali? I go and use like HNO3 and then go like use like KOH. Do you think this chemical can give you NaCl? Cannot, ma, doesn't make sense, so you have to actually use, you're gonna actually focus on the salt that you want to produce and then try to brainstorm what you're gonna use in the front. Okay, so if I want to produce Na and Cl, my acid must have Cl, my alkali must have Na. Like that, no? Okay, so that's why you see, once you decided what acid to use, what alkali to use, then you can do the titration method. Remember this method, titration. Okay, so on this case, okay, so with the step down, you see you got 1, 2, 3, 4. So you're going to do a titration where you actually drip your acid, okay, into your alkaline, and then you turn your phenolphthalein from pink to colorless. Then your reaction is fully complete. Okay, but then when you turn your pink to colorless, is to neutralize, okay. But usually, after the first neutralization, you're going to repeat the experiment without phenolphthalein, because if you actually turn pink to colorless, your salt produced inside got phenolphthalein as the impurities. So that's why always you do like titration already. Okay, titration you finish already. Then you always have to repeat without phenolphthalein. Okay, because if you don't repeat, your salt inside got phenolphthalein, it will affect your purity of your salt. Means your salt inside got phenolphthalein. So later on when you give a teacher or your teacher give you the salt inside got phenolphthalein, then it's something wrong. Okay. So you do the first time is to get the amount of acid to actually use to neutralize the alkali at the bottom. Okay, so once you know, I need like 25 cm cube of acid, then I can actually repeat the whole thing. No need phenolphthalein, I just put 25 cm cube. Okay, so you do one round first to find the amount of acid needed. Once you know the amount of acid needed, then you just do without the phenolphthalein. Okay, so this will be your titration method lah. So after you repeat it, then you get your salt is in solution form, which is in water. So usually we want to get your salt in solid form. So after you do this already, then you're gonna do heat, cool, filter, rinse, and dry. Remember last time I teach you all how to remember. Hippo can fly, really dangerous. Remember this? So we're gonna actually do this is to heat, cool, filter, rinse, and dry to get your salt from solution, okay, from this solution into salt solid like that. Salt crystal. Okay, so actually the last 5 steps is to get salt crystal, not to form a new salt. Is to turn your salt solution into salt crystal. Okay, so this method only needed for soluble salt. You know why? Because soluble salt come out as liquid. Insoluble salt come out as solid. So come out as solid, no need to do heat cool. Okay, heat cool is to actually heat and evaporate your water so that it becomes like very saturated, and then eventually you cool it down, it will become salt crystal. See, heat and cool is for crystallization to occur. Crystallization is like you want to get salt out from water. Okay, but then if your salt is already insoluble, then no need lah. Okay, so wait lah. Okay, so once you actually collected your salt crystal, then this is your thing that the teacher can keep in your science lab, and then your teacher can give it to you. Okay, so this is your salt crystal. But then this is for what? This is for soluble spark. So if you want to produce soluble non-spark, like what you see? Okay, by the way, guys, there's a discussion at the next page to let you know like what are the common questions in exam. Okay, so if it's neutralization, this is the stuff that you have to ask lah. Why we use phenolphthalein to determine endpoint? Okay. Then why we actually have to rinse? Why we actually have to like give other sample and stuff? Okay. So this discussion I'm not going to go in details now. Later we do exercise, we can refer back. Okay. Then this is describe experiment. Okay. Because not right now, right? Some of your paper 2 exam teacher like to come out right procedure. Describe experiment. So we try not to avoid this this type of question. Okay, so if your teacher come out this in section C, high chance is what? Your salt preparation, or maybe your technically any experiment they can ask you in procedure also got chance. Okay, so what they do is, let's say if an exam asks about neutralization, this will be the steps you have to go through. Okay, so I will say, guys, don't have to go exactly the same lah. Okay, the teacher need to memorize so many things. I mean, memorization cannot avoid okay? But then you can actually memorize in a picture way. Okay, you can just try to memorize all the keyword. Okay, what do you do? So in exam, you just roughly draft out the procedure. Usually, I don't expect you all to get procedure full mark one. Okay? If you get procedure full mark, you need to be exactly the same as this. No one can do this unless you're a robot. You think you check GPT? So impossible to actually like go exactly the same as this one. So what I prefer to you guys to understand is at least you understand, and then you have it in your mind that how this whole experiment can actually go in sequence. Then you just draft out on what you remember in exam. Okay, so maybe your procedure is like 5 mark. So if you get like 3/5, already very happy. Okay, so procedure, don't struggle too much, okay, guys. At least you know how it goes. It's more than enough. So usually I do what? I memorize the picture. Neutralization is like this titration method. Then I roughly know how titration do. Then that's all. So I know must acid on top and then alkaline at the bottom. And then alkaline at the bottom I've got phenolphthalein. And I will treat my acid into my alkaline. Like that. So just read through the procedure, no need to like struggle too much. If you struggle too much on procedure only, you're gonna waste your time and then no time for other stuff. Okay, so this one is just procedure writing. Okay, describe experiment. This one 10 marks so you try your best lah. If you get like half of this, I'm actually happy enough. Okay, so of course after this one, then you can go for the second method. So second method, no specific name. Okay, no reaction name, no method name. Okay, but the trend is what is you take acid plus metal carbonate, metal oxide, or metal hydroxide. Okay, so what we can do here, you see, why are we gonna use this acid and this metal? Because obviously it depends on your salt that you want to produce. So if you want to produce CuNO3, same thing, like just now the same case on acid alkaline. If I want to produce NO3, I need to think about an acid that got NO3. But can't I go and use HCl? Because HCl only can give me Cl. Here don't want Cl, here want NO3. So what acid got NO3? Then we know this nitric acid. Then you see why we use copper carbonate, copper oxide, copper hydroxide. Anything that has copper is okay. Why? Because you want to form copper nitrate. So my metal must have copper. If you go and think, teacher, can I use like magnesium carbonate? Doesn't make sense. Magnesium carbonate give you magnesium salt. If you have copper salt, you want to form copper salt, then use copper metal. Okay, but then one mistake here, not mistake like one very tricky part is usually the first method is not suggested. Okay, why the first method not suggested? Because it doesn't work on copper. You know why? You imagine like if I want to produce a magnesium salt, let's say if I say I want to produce MgNO3, okay, but then if I use HNO3 plus Mg, actually this one okay, this one work. Okay, why? Because actually acid and metal is a displacement process. Means that magnesium is able to displace H and snatch the girlfriend, become MgNO3. But copper cannot. Because copper, why? You all learned before, remember? The reactivity series, copper not enough, not strong enough to kick off the H. That's why no reaction here, because copper is less reactive. So that's why I always to avoid getting a wrong answer in exam, right? Okay, you can either memorize in this way. You can use all method, okay, for any method except for copper. Copper cannot use first method. The rest actually can. Why the rest can? Because the rest is not snatch girlfriend. The rest is exchange girlfriend. You see, Cu, NO3, and then H and CO3, like exchange partner, this and that, okay? So if you exchange partner, you don't have to check like reactivity series. Only if you snatch the girlfriend, then only you need to check reactivity. So you see, copper no reaction, it's because copper not strong enough, not reactive enough. So that's why you see like something like this happen, okay? Then you see like you see all this you see like copper, if you see got carbonate, then got carbon dioxide. If you just see metal oxide, metal hydroxide, you just form water like that. Okay, so usually exam they like to ask you which one. Usually they like to ask you the second one. Why? Because second one can actually collect carbon dioxide. Then they can ask you one more question: how to test the carbon dioxide? Remember? Guys, how do we test the presence of carbon dioxide? Any idea? So this one is like an additional question. Correct. Lime water. Lime water become what? Turn milky, turn chalky and stuff. So like let's ask like a bunch of procedure and then question, and then they suddenly go and like ask you how to test carbon dioxide. So this is what they like to ask because they can ask like one more question out of topic. But then this out of topic, but then still under our syllabus lah. Okay, so carbon dioxide turns lime water milky, chalky, cloudy. Okay, so this one is the second method. So second method, you see, like you are actually just taking acid, then you plus all this all these are actually got one similar thing. It's actually all solid. You see, so technically you are like making Milo, making coffee. You pour the powder into the acid. Okay, then you pour already. Of course, this acid must heat lah. Okay, you have to heat this acid. Okay, and then stir it, and then eventually, when do you stop a reaction? So you actually pour your powder. You never say you pour 5 gram, 10 gram, 15 gram. No, the powder must pour until it cannot dissolve anymore. We call that excess. Remember that? So why must pour until excess? Because if you pour like 1 spatula, 2 spatula, then your powder dissolve. Your acid still got a lot. So means your reaction is not complete. Means you have your salt inside, but then acid still got left over. Means right now your product is acid and salt mixed together. I don't want that. I only want pure salt. So how to get pure salt? I must make sure all my acid all fully reacted. How to make sure all acid fully reacted? Powder add. Keep adding powder until the powder cannot dissolve. Means acid no more already. But then of course we have to filter out the excess powder. You see, that's why you see after we add the powder, always filter the first time. Okay. Why do I say filter first time? Because later on you're gonna do heat, cool, filter, rinse, and dry again, correct? This is actually cannot avoid one. The hippo can fly really dangerous. Cannot avoid because what you produce here is a soluble salt, so soluble salt must do the heat cool for crystallization, and then you have to filter, rinse, and dry to get the salt crystal. Okay, so in this topic, you filter the first time, you filter second time. So why need to filter 2 times? So the filter the second time, this one confirm got already, the one also in the previous topic, previous neutralization. This is the one that is extra. Because why? Because this reaction is you add powder until excess cannot dissolve anymore. Then you can actually filter the extra powder, because when you pour your powder until cannot dissolve, your salt is complete, but then your salt inside got extra powder. That one also you don't want to actually keep that. So you filter the extra powder away, then you get your pure salt. So this is your pure salt. Okay, but then still in liquid form. So we're gonna do heat, cool, filter, rinse, and dry. Okay, so this is the second method to produce soluble non-spar. Okay, neutralization is soluble spar. For this one, this one is not for soluble non-spar. Okay, so if okay, then from here, you see after we know like your discussion and stuff, then again later we're gonna do question on this lah. You see, again, describe experiment. So we give you like discussion and describe experiment after the topic every time. Okay, so anytime when you need to refer like, oh, procedure, you can think about the seminar notes, got procedure given. Okay, then finally the third method is for you to produce insoluble salt. So how to produce insoluble salt? Okay, so insoluble salt is supposed to actually have your method 3. Okay, so you're gonna do double decomposition, or we can call it the precipitation method. So what is the rules for this method? The rules for this method is supposed to be, remember last time I said before, what is this and what is this? We call it the what? Soluble salt plus soluble salt. But of course the soluble salt and soluble salt must go according to your salt you want to produce. Imagine I want to produce BaSO4. Then one of my soluble salt must have Ba, the other soluble salt must have SO4. Like that, only you can combine exchange partner to get BaSO4. But then who will be the partner for Ba? Who will be the partner for SO4? Doesn't matter. As long your the Ba partner and SO4 partner allow them to become a soluble salt, it's all okay one. That's how you see BaNO3, Na2SO4. If I use K2SO4 and BaNO3, actually still fine. I go and use ammonium sulfate and then barium nitrate, also still can give you the BaSO4. Because why? Because as I said, as long your soluble salt inside got Ba, your soluble salt got SO4, both soluble salt can react and exchange partner, you can get your BaSO4. But of course, you get a different side product lah. But then this side product doesn't matter. You know why? Because once you produce your BaSO4, it's an insoluble salt kind of. This one is insoluble salt. Insoluble salt means what? Solid. And then this one is a soluble salt. Means it's a what? It's a solution. So it's actually a solid inside a solution. So your end of your reaction is like this. You see this picture? So means this one is the easiest method among all 3 methods. Okay, because these two this one here is just to take soluble salt, 2 beaker, pour together, stir, stir, stir. You don't even need to heat. Okay, stir, 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 then you get this. And then how to collect this insoluble salt? Filter. So you see, filter, rinse and dry. Don't even need to heat, don't even need to cool, because heat and cool is for crystallization. It's to turn soluble to solid. But this one already is a solid, so no need to heat, no need to cool. Just filter, rinse and dry. Okay now. So you see, these are the 3 methods to actually produce your salt. So next time in exam, right? If you only want, if they ask about like suggest a method or maybe like describe a method to produce a certain salt, you want to think about, is it soluble spar, soluble non-spar, or insoluble salt? So these 3 confirm among these 3 one, okay? So you're going to choose the correct method to write in exam, okay? So after salt preparation, then we're going to actually, again, guys, you see like the discussion and then the procedure and stuff. Okay, this one I'm not going to go through, don't waste time here. Okay, then you move on. In the next page, you will see your color of salt. So color also very important. Why? Because color is for you to actually recognize what salt is that. You see blue color, what salt is it? You see green color, what salt is that? Okay, so your color also very important. You see Cu2 plus usually is blue color. That's why we put Cu2 plus blue color. But then Cu2 plus very special is usually he's blue color. But then sometimes he can become green, sometimes he can become black. Okay, so it depends on what partner he having lah. Okay, so Cu2 plus usually is blue, means with SO4, NO3, OH is all blue. But then if you see CuCO3, green. CuCl2 also green. Then you see CuO. This one is CuO. CuO is black. Okay, so means when you pair with different partner, he will get different color. Okay, so this is a special part about Cu2 plus. Then Fe2 plus no special, confirm all green. Fe3 plus confirm all brown. Okay, doesn't matter one. Okay, so this will be the color, and then other salt is white. Okay, we have a little bit of special salt. Usually you see the brown when hot, yellow when cold. Yellow when hot, white when cold. Okay, so usually how I memorize, you see this one. P is for peanut. Is it peanut? Why? Because before you cook peanut is yellow. After you cook peanut, the color become darker, become brown. So yellow when hot, yellow when cold, brown when hot. Okay. Then for Zn usually is zebra. Zebra. Why? Before you cook zebra is white color. After you cook zebra is yellow color. Don't ask me how I know. Okay, no guys, I never eat before zebra meat. Okay, just saying. Okay, is it the color changes important? Of course, color changes is very important. Okay, because if they ask you about color change, they say, salt A is brown when hot, yellow when cold. Then they ask you what is salt A. So you ask me whether it's important or not? Definitely very important. So salt color very important, because color is one of the easiest way to recognize what salt is that. Okay, even though it sounds very racist. I see. Wow, yellow skin, Asian, Chinese. But then color very obvious, you see your color of your salt, you know it's actually supposed to be this salt. Okay, you see blue, confirm Cu2 plus. You see black, CuO. You see green, can be CuCO3, CuCl2, or maybe Fe2 plus. Up to you. Okay, so green color is the one that you need to think twice. Okay, because green color got many people green color. But then if you see brown color, confirm Fe3 plus. But if you see brown and hot, yellow and cold, that one not Fe3 plus. The one is PBO. You see the difference? So it means every color you need to know who the color is for who. Then you know who is it. Okay. Important. Okay. Then PbCl2 is white, PbI2 is yellow. These two color is fixed. But then these two salt, the color don't change, but the solubility change. Means that insoluble in cold water, soluble in hot water, insoluble in cold water, soluble in hot water. Means this type of salt, this PbCl2 and PbI2, if I throw into hot water, he disappeared. But if I cool down the water, I throw it to cold water, he remain as solid. Very magical. Okay, so this one, he will dissolve according to the temperature of the water. Okay, that's why we call it soluble in hot water, insoluble in cold water. Okay, so once we know the color, this one guys, just to let you guys do some test of yourself see. Okay, let's say solid X is green in color. Then you say, green color got who? Green color can be Fe2 plus, okay, or CuCO3 or CuCl2. Remember? Green color got three possibility. Fe2 plus salt or CuCO3 or CuCl2. How do I double confirm the color, this green color is who? We're gonna actually do some tests. You see, I add distilled water, okay, it still gives you green precipitate. Okay. But if you see green precipitate, high chance is CuCO3. Why? Because CuCO3 is insoluble in water. You get it? Okay, but if this solid X, green color solid X, it can dissolve, then high chance is Fe2 plus, because Fe2 plus is soluble salt. CuCO3 is insoluble salt. You see, just by one green color and then just dissolving into water, you can get two different possibility. And then if you see you dissolve already, it gives you blue color. Then it might be CuCl2. Which is actually why blue color? Because Cu2 plus is blue color. So you see, just one solid X that is green color, I dissolve into water, I will have three different possibility. Which one match my observation? There I need to know who is it. If I dissolve in water, then maybe give you green solution, then maybe it's iron 2. If I dissolve in water but give you blue color, then it's Cu2 plus inside. If I throw into water but never dissolve, then the green color solid is supposed to be CuCO3. You see, different solubility also very important. Not just color, color already know, already, then solubility must pair together to know who is it. Okay, because different salt, different color, different salt, different solubility. So like solubility, color, all these things is for you to recognize who they are. That's why. Is it important? Confirm important one. Okay. So of course this one okay, done already. Okay, then if you see the next one, if you heat your salt, also will have different observation, then we can recognize who they are. So means if you heat your salt that has carbonate, teacher, FeCO3 is soluble. FeCO3 is soluble. No, FeCO3 is insoluble. FeCO3 is insoluble. So if you put FeCO3, then it's green precipitate. This one, there might be CuCO3 or iron 2 salt, which is insoluble in water. You see, the sentence here can be. So if you see green precipitate, then can be CuCO3 or maybe FeCO3, like what you said just now. Then what salt is the Fe2 plus for soluble? Like FeCl2, FeCl2, FeNO3, 2. You have to pair with those soluble ions. Okay. Don't pair with the insoluble ions. Then can you? Okay. And okay, so this one. So this one is iron salt which is insoluble. This one can be what? Can be FeCO3, can be FeO, can be FeOH2. Okay. What is iron salt which is soluble? Usually can be FeCl2, maybe like FeNO3 too. Give you the different possibilities. That's why I always tell my student, okay, this topic is like you guys being a detective. Okay, you need to actually find like tips, okay, find like some certain information, and then you try to predict who is the murderer. Okay. So it's like finding out who's the salt inside your solution, who's the salt inside your chemical here. Okay. So this topic is very hard, but then sometimes it's interesting maybe not for you all. Okay. For me very interesting because I see this color, I know who is it. I see that color, I know who is it. Okay. So if you're moving down, okay, so you see, heating of salt, if you heat carbonate salt, carbonate salt is what? Any salt with this one, CO3, 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 CO3. Any salt with CO3, you heat, confirm got CO2. Okay, and how to test CO2? Lime water turns milky. Okay. Any salt that you heat with nitrate, okay, NO3, you heat got NO3, confirm got NO2, and then confirm got O2. Okay, so you see, this is like a fixed trend. Okay, then you know NO2 is brown gas that turns blue litmus paper red, and then O2 is giving you a glowing splinter relight observation. Okay, so guys, so this one here is like again, I do this test, and then I see this observation, I know what is the gas. So example, like ask you, gas X turns lime water milky. What is gas X? Carbon dioxide. Then by having carbon dioxide, predict what is salt X, what is salt A. So like they tell you this is A, okay? They tell you this is X, okay? So if I got X, means that my A confirm got carbonate salt inside. So this is like a backwards analysis. You get it? So I give you the product, okay? Find out what's the product already. Then you predict like what is actually in the front. Okay. So later we do some question about that lah. So after the test, okay, after this gas test, this is heating test, then we got gas test. So gas test there, just now we talked about a bit already, like CO2, we talked about it already. Then O2, we also talked about it already, but we got other gas, you see. What if we got H2? How to test? Lighted wooden splinter, give you pop sound. How to test ammonia gas? Moist red litmus paper turns blue. Then how to test hydrogen chloride gas, HCl? As you know, HCl is like acid, guys. Am I lagging? Testing. No, can hear my voice clearly? Because my screen is lagging though. Because I'm actually scrolling my screen, but it's actually your face is moving. So my voice okay, my face okay lah. Just that the iPad screen something wrong. Hello. Hey, okay, it's back. Is it back? I'm scrolling up and down. You can see it. Okay. So to test like hydrogen chloride, it's acid, so you turn your blue litmus paper red and something like that. And then nitrogen dioxide gas, chlorine gas, all these gas. So hopefully these gas later we refer to here. So I don't expect you all one day can memorize everything, okay? So, but at least I need to train you all to use these notes, okay? Because the point of these notes is not it's not for you to memorize right here, right now, okay? It's for you all to actually later on when you all do your own practice, you all know how to use, okay? So once you know this already, then these are all the test observation, and lastly, you got anion test. So anion test only got 4 possibilities, okay? You got four types of negative ions, again with 4 different tests. So test for carbonate, you can actually either you add acid, you produce carbon dioxide gas that turns your lime water cloudy. To test chloride, we will add AgNO3 and you'll form white precipitate. To test for sulfate, you add barium nitrate to get you white precipitate. Test for nitrate, give you a lot of stuff, you see, plus sulfuric acid, plus FeSO4, plus concentrated sulfuric acid, you will see a brown ring. So these are like all the specific steps, specific procedure for every types of anion. So if anion got test, cation also got test. So you see Pb2+, how to test Pb2+? I'm going to use potassium iodide. To test ammonium, I'm going to use Nessler reagent. And then you will get different observation, yellow precipitate, brown precipitate. Test Fe2+, I'll add potassium hexacyanoferrate. You will see dark blue precipitate. Okay. Test Fe3+, I'm going to use potassium thiocyanate. You get a blood red solution. Okay. Test copper 2+, I will add excess ammonia. Okay, you add ammonia, you will see blue precipitate. Then you add excess ammonia, you see blue precipitate dissolve. So these are like multiple tests for different chemical. And then eventually when we go for cation test 2, okay, remember this ZAPCM table? Okay, my screen is lagging again. Testing. Ayyo, my screen lagging again. Hello. Okay, my screen is back. Yeah. Okay. So guys, remember how to do this test, Okay, how this works is like elimination test. This is like test 1, this is test 2, this is test 3. So if I want to check whether my salt inside got this 5, either one of it, I'll do test 1, and I see which one match my observation, and then I do test 2, I see which one match my observation, until the box, the observation, that actually can have one chemical only. So what actually ZAPCM stands for? Stands for Zn2+, Al3+, Pb2+, Ca2+, and Mg2+. So the method of using this table is to go step by step, okay? Because you see step 1 give you Wp with a tick is actually representing ZAP. Then Wp with a cross there is representing Ca and Mg. So you need to actually like use different multiple methods. Only you can find like, oh, you see, if you can actually do second test, then you found the first one, the first observation match your observation, then your answer is zinc 2 plus. If you do second test, you see, oh, WP with a cross, then you see is Mg2 plus. Okay. So basically, guys, WP is what precipitate, NP is no precipitate. Okay, different type of precipitate lah. So then YP is yellow precipitate, NP is no precipitate. So by doing like this, you see the trend. So this one actually in a flow chart is. So let's say I have 2 cm³ of a salt solution. So this salt solution is unknown. I don't know who is inside. So I will do my test one. Okay, I will add few drops of sodium hydroxide, and then I will see shake the mixture. Okay, if it's no precipitate, then eventually I will test it with moist red litmus paper. I heat it. I confirm is having ammonium ion. Why? Because if you add few drops of NaOH, you see, adding NaOH, this is the first row. Okay, you see the first row. Actually, until all the way until the end also can. Okay, yeah. If I add NaOH and you get no precipitate, actually no precipitate is only ammonium. So means if you do test one and you get this observation, then your answer confirm is ammonium. So I can do a second test to confirm that this is ammonium gas, ammonium ion. Because after I heat ammonium, it becomes ammonia gas. So ammonia gas we test with red litmus paper turn blue. Okay. But what if I add NaOH and I get like a white color precipitate? So white precipitate is this two. White precipitate. You see these two white precipitate. But then white precipitate got two types. One is thick, one is cross. So white precipitate thick means it will dissolve. Cross means do not dissolve. So what's dissolve and do not dissolve? You see, after add few drops of second test, if I get white precipitate, I will add excess ammonia, sodium hydroxide. Okay. So when I add excess sodium hydroxide, that will be the thick and cross. Okay. That's how you see. When I add excess sodium hydroxide, okay, shake it evenly. If the precipitate dissolve, ZAP. If the precipitate do not dissolve after you add excess, that is Ca and Mg. Because this is WP with a thick. This is WP with a cross. You get it? So you go in flow chart. Okay, you go in like this flow. If this observation, you do this test. If that observation, you do the other test. Okay. So this is like a step-by-step guidance on how to actually use this table. So this table is a simplified version of all the observation, WP with a thick, WP with a cross. So thick and cross stands for soluble or insoluble. That's how you see. I add a bit, get white precipitate. But white precipitate, I will add excess. Then my white precipitate will have dissolve and do not dissolve, two different possibility. So if dissolve, then my answer is ZAP. If do not dissolve, then my answer is Ca or Mg. Then you're gonna do second test. Second test, I add ammonia. Then again, if I check no precipitate, is Ca or Ca2 plus or NH4 plus. If the precipitate actually dissolves, okay, then again I add excess ammonia. I get precipitate dissolve, then is Zn2 plus. If I see precipitate do not dissolve, I see AlPb Mg2 plus. Okay, all according to what? All according to the ZAPCM table. So this one, later you're gonna actually use the question, and we're gonna practice using this, how to use this table. So all these are just sample. Okay, sample with different possibility. Okay. Then of course, guys, you see there are some basic practice here given with answers lah. So you can, before you go for like exam question now, you can do your own self brainstorm using this page. Okay. For example, you see this is for heating of salt lah. Okay. If I heat a copper 2 carbonate, what happened to it? If I heat copper 2 carbonate, it will decompose, become CuO and CO2. Then we know CuO is what color? Black. Okay. So means in exam, even if I don't know what is this, they tell you this is salt A, and then they say after heated, you get a black solid. Then you know confirm is CuO. Like that, no? So exam got two ways for asking. Either they give you the salt, and then they ask you observation, or they give you observation, ask you what is the salt. So actually only two possibility. Either give you observation, then ask for your salt. Either give you salt, then ask for your observation. Just a reversible way of asking. Okay. So these are all the tests. As I said, I don't expect you guys to memorize in one day lah. Okay. So, but at least I need to train you guys how to use the notes. Okay. Come, let's try to go for some salt test question again. So salt test question is, let me see, a question. Let me see. Question 10. Come guys, go to question 10. Okay, which is page number 27. Question 10, page number 27. Teacher, when I study, should I use the 3 notes of salt chapter or just this book? This book is for quick revise because the question here not enough one. If you want to like master this chapter definitely you need to like finish the question in the previous book from last year. But then if you don't have time, you say, teacher, oh, I need to study other subject, then at least finish this book. Okay, can actually like secure your marks here. But the learning pages same, right? I mean, learning pages is what? The exercise, these are the exercise we actually take out from there. The notes part is the same, of course. Notes is the same. This one is actually a simplified version. The notes one in your previous last year book is more detailed. So this one is like short notes. Okay. So here, if you can at least do this first, finish your seminar book first. Then if you got time only, you go for last year book lah. But I believe no time. The rate of reaction, rate of reaction, why? Rate of reaction, you can use last year book. I think rate of reaction only got one part, right? Only got one book. So you can use the one from last year. Okay, let's see, guys. So right now, you using your short notes in the front, try to brainstorm all the tests here. Okay, so we have solution A, B, C, D, E, then got different color, different observation when add sodium hydroxide, different observation when add ammonia solution. So let's say, guys, I do A for you. They say state the cation ion for A, B, C, E. So A, B, C, E, they want cation ion. Cation ion means positive ion test. So what is the positive ion test? The ZAPCM table. So how to test it? Okay, number one. Do you realize that A is actually blue color? Guys, blue color, what you can secure? If you see blue color, in your mind must have at least one thing already. Why? Because who is the only blue color ion in your whole chapter? Is your Cu2 plus. Okay. So to double confirm whether is it Cu2 plus, okay, guys, you see, let me use the notes in the front to guide you through. Okay, so do you see here they say when I add sodium hydroxide, you see blue precipitate insoluble in excess. When I add ammonia, blue precipitate soluble in excess. Let's check whether is that the test for copper 2 plus. So you go back to your notes. Do you realize that when I add sodium hydroxide, you get blue precipitate for Cu2 plus. When I add ammonia, you get blue precipitate that will dissolve in excess ammonia, which is matches the observation, all of it matches under Cu2 plus. So my cation ion for A confirm Cu2 plus. Okay. So that's why from here. This one confirm already. So A is Cu2 plus, then correct. Okay, give yourself a tick. Okay, give yourself an applause. Good job. Okay, but this is only for A. A very easy because whenever you see blue color, actually very obvious. The hard part is when you see something like colorless. You see, B tell you is colorless. Colorless is the hardest one. You know why? So many things is colorless. Is you're gonna do a lot of tests just to find out who is the colorless. Okay. So since colorless got no information on it, then you see the first test. Sodium hydroxide add already, get you white precipitate that is soluble in excess. So let's go using this one. Let's go to our notes first. I want actually white precipitate that is soluble means a tick, WP and a tick. So go to your ZAPCM table, go to this sodium hydroxide test and find WP and a tick. So what is WP and a tick? This ZAPCM table, NaOH test, WP and a tick is this one. Correct. So WP and a tick with the first test, what can you conclude? My conclusion is after the first test, my answer can be Zn2 plus AL3 plus or PB2 plus. Means after first test, my possible answer can be ZAP. Get it? But ZAP is not a final answer. ZAP is just like 3 answers. So how to get complete answer? You see, I do second test. With ammonia solution, I will see white precipitate that is soluble in excess. Again, WP with a tick. But this one under ammonia. So go to the ammonia test. Yeah, let me go back to the notes. Ammonia test. This one, ammonia test. This one, ammonia test. Okay. The whole row of ammonia test. Do you see WP with a tick? The whole row. Okay. Correct. Do you see this one? WP with a tick. And WP and a tick belongs to which ion? Belongs underneath of Zn2 plus. Correct. Because you see this WP with a tick is the box under the Zn2 plus. So means your answer right now only left with one choice. So if your answer left with one choice, that's your final answer. Okay. So after second test, I can conclude that here is Zn2 plus. You get it? So A got Cu2 plus, B got Zn2 plus. Can you guys try C? C give you light green color, and then after sodium hydroxide, give you dirty green precipitate. After ammonia, still dirty green precipitate. So guys, who you think this green color is? After the color, the test 1, the test 2, who do you think this C is? You can refer to your notes. Okay, refer to your notes in the front. Okay, guys, refer to your notes in the front. So in this case, yeah, guys. So actually, after you check, no matter what you do, you see green precipitate. So who is the one that, no matter what you do, you always see green precipitate? Correct. Fe2 plus. Okay, so that's why my third answer here, Fe2 plus. Okay, so this is easy. How about E? Okay, the one E, E is colorless again. White precipitate insoluble in excess. White precipitate insoluble in excess. Right? This one. Try to find out what is the answer for E. Okay, not doing D, guys. Because they only want A, B, C, and E, so they skip D, or I don't know why, but then we follow. So what is the cation in E? Come, give you guys some, like a little bit of 1 to 2 minutes to brainstorm. I want, my observation here is white precipitate insoluble, WP with a cross. Okay, the other test is also WP with a cross. So what is the ion? I add the first one, WP cross. Second one, WP with a cross again. So go to your table again. Yeah. What is the test? Okay, test 1, test 2. I mean, like, we do the 2 tests already. Which test, which is the chemical, the ion that always give you WP with a cross? So see, test 1, who give you WP with a cross? This one, Ca or Mg. Then test 2, who give you WP with a cross? Got 2 answers, but as I did the first test, right, I can technically eliminate the ZAP already. Because test 1 is to let you narrow down your answer from 5 choice, from many choice to 2 choice. Okay, you get the point. That's why you need like test 1 and test 2. Because sometimes you see test 2 got 2 same observation. So you need like test 1 to actually narrow down your possibility. So the purpose of having test 1, the sodium hydroxide, is to narrow down your choice from these 5. After my test 1, I confirm no, this 3 is out. So this one, even though it's still, it matches my observation, but it's not falling into my choices already. Because according to test 1, ZAP confirm out. Okay. So what is the one that actually give you WP with a cross? Test 1. And then WP with a cross, test 2. So WP with a cross, test 2, under who? Under your Mg2 plus. You see that? So it means you have to repeat your experiment. You do like multiple tests until you get your observation fall into one box. And that box is the answer. So that box under who? That is your answer. So means answer here supposed to be Mg 2 plus. So that's why you see my answer. Okay, A is copper 2 ion, Cu2 plus, correct. B is Zn2 plus, correct. C is Fe2 plus, ion 2, correct. E is magnesium 2 plus, and it's an ion. You see? Okay. Guys, you see how it works, You have to refer table, find observation. So this one is what? They give you observation, ask you to find out who is the ion. So this is a type of question, like type 1. Okay. Like of course you have type 2 lah, like, or I can say like, oh, I give you the ion, then you describe the test. So the one I would say harder lah. Because describe test, you have to do like, you have to write in details. Okay, so on this case here, wait. Okay, so guys, if okay, can you try to do B? They say state another test to identify C. So C is Fe2 plus. This time we get already. So Fe2 plus, beside doing the sodium hydroxide test and ammonia test, do we have a specific test just for Fe2 plus? Then you go back to the notes, you see. Fe2 plus is always green. Do we have a specific test for Fe2 plus? You go back up. Test 1. Fe2 plus, that's fine. Easy. See? Fe2 plus is green, right? But we can do 2 specific tests. I can either test with potassium hexacyanoferrate 2. I can also test with potassium hexacyanoferrate 3. I get 2 different observations. So it depends on which one you want to use. But I always prefer which one? I always prefer the hexacyanoferrate 3. You know why? Because we also use this in math. Remember we learned this topic in chapter 1 from 5. We learned rusting. To test the presence of rusting, we use this one, correct? You get a dark blue precipitate. So I prefer this one because here you use, and chapter 1 also you learned before. Chapter 1 we use it to test the rusting of iron. Okay, so this is the special test for iron 2 plus. If you want special test for iron 3 plus, also got. You see, you got 3 different ways. But I will prefer the highlighted one because this highlighted one is a very special test. Like Fe2 plus cannot use. So these are only specially just for Fe3 plus. So you see potassium thiocyanate, you get blood red coloration. Okay. So that's all from here. Yeah, the test we're gonna use the potassium hexacyanoferrate 3. That one I prefer. So you see my answer here is I will put 2 cm³ of C into a test tube. I'm gonna add few drops of potassium hexacyanoferrate 3 solution, and a dark blue precipitate is formed. Okay. So hopefully you guys actually can catch up, guys. Okay or not? You all never say anything, hopefully you're not dying behind the screen, Did you update? Cat ion test 1 harder than 2? A bit, because cat ion test 1 is all specific chemical indicator names like potassium hexacyanoferrate 2, Nessler reagent. But test 2 is just about sodium hydroxide, ammonia test. Right? So I will say, test 2, test 1 slightly harder. Okay, guys, can I? Okay, moving on. Okay, what are the possible cations present in solution D? So D, they never ask you, but then now they ask you in C. What are the possible cations? Okay, so there's a trick in this question. They say possible cation means there might be more than one answer. It means in this observation here, you might not get your final answer even after the 2 tests. Let's see. D give you white precipitate soluble in excess when you add sodium hydroxide. So it means this one here is white precipitate. Let me use a different color. This one is white precipitate soluble, so WP with a tick. Okay. Then ammonia test is white precipitate insoluble in excess, so WP with a cross. So find the ZAPCM table. Sodium hydroxide test give you WP with a tick. Then ammonia test give you WP with a cross. Okay. So with this understanding, let's go back to our table again. Yeah. Okay. So test of sodium hydroxide give you WP with a tick, which is this one. So test 1, I know my answer is ZAP. Then test 2 give you WP with a cross, which is this. So means now my answer, I can eliminate Zn. But then I still got how many choice? Under WP with a cross on the second test, the ammonia test, I still underneath AL and PB, right? So that's why the answer here is more than one answer. Because after two tests already, you actually still have your observation still under two ions. So you see my answer here is actually Al3 plus and Pb2 plus. So the two possible ions is aluminum ion and Pb2 plus, the lead-2 ion. Okay. Usually the question after this one is to ask you how to test. See, briefly describe a test that can differentiate the cation ions present in solution D. So which is right now, your C answer is Al3 plus and Pb2 plus ma. So you still don't have a final answer. So how to get your final answer? So if you go back to my table, if this one cannot give you final answer, go for the last one. Add potassium iodide. If you see no precipitate, it's aluminium. If you see yellow precipitate, it's Pb2 plus. So that's the thing you have to write. Because after ammonia, you still get two answers. So haven't finished yet. So I do the last test. Okay. If you see no precipitate, Al3 plus. If you see yellow precipitate, Pb2 plus. Correct. So my answer here must include both answers. Include both observations. So my answer here is it? Add 2 CNQ of solution D into a test tube. Then you add potassium iodide. If you see yellow precipitate, is Pb2 plus. If you see no visible change, which is like no precipitate, is Al3 plus. Okay. Guys, okay not? Still going strong? Or falling soon? Or already fallen? Okay. So this one is it. You want to test this one? So after you finish writing, try the next question yourself. The next page. Yeah, let me check the back end again. You want to try next question again? Teacher, no visible change should be white precipitate disappear because it's no no NP means it's supposed to be just straight away no precipitate. White precipitate disappear supposed to be WP thick. Means you first see one precipitate, then only dissolve. That one is WP, then only thick. But if you straight away see NP, actually never appear before. NP is straight away never see before precipitate. You get it? NP means never see a precipitate. straight away you throw, then everything disappears. That one is MP. If only exam give the table, life will be so much easier. Hey, I tell you, this table, everyone, hopefully exam will give, too bad, exam will give. But you know what? In IGCSE, you know IGCSE, the international syllabus, in the recent year, I mean last year, they updated their syllabus, the structure. They actually provide the table in exam. Last time also don't happen. But suddenly they update syllabus. They say, this table let us put inside exam. That's why Asian getting smarter. You see, IGCSE syllabus are so easy already. Somehow still want to give a table. So really no need to use brain one. I mean, like, no need to, they need to use brain, but then no need to memorize. So kesian SPM from 5 kids, right? Yeah. Okay, guys, done. Let's try the next one. Okay, in this case here, okay, we have test 1, test 2, test 3. Okay, test 1 is sodium hydroxide. You see white precipitate. Add ammonia, you see white precipitate. Add potassium iodide, yellow precipitate. So from the table, what is the ion present in the water? Guys, actually, in a very straightforward answer, if you see white, yellow precipitate, if you can think about it, your answer already appeared. You know why? Okay. Peanut cold and yellow. Yellow and cold. That one, I mean, like, high chance. Possible. So yellow precipitate. If you say peanut, peanut is what? So supposed to be how is it? If you think about yellow, you think about peanut, right? Or you think about this one. You see, do you see here also got yellow precipitate, which is actually Pb2 plus. Okay. So means from here, guys, you see, my answer already, I know it's actually lead to ion. I straight away skip test 1, test 2. I see yellow. I know who is it already. Okay. So what is the purpose of doing test 3? Just like I say, actually test 1, test 2, if you see white precipitate, most likely you get multiple answers. Means you don't get your final answer yet. So it's actually to confirm the presence of Pb2 plus. Okay, guys, all good. My cat's so good boy, sleeping all the way. Okay, now, if sodium chloride is added to water, state the observation. So now, if you actually like add sodium chloride into this water, so what happens supposed to actually happen to this the new salt that you've actually produced? So just now we say again, inside here is having Pb2 plus. Means like inside this chemical here, inside got Pb2 plus. But then now you go and add like sodium chloride. What is sodium chloride? Sodium is Na plus, and then chloride is Cl minus. So ask you one question. If now I know my chemical here got Pb2 plus, Then I add sodium chloride. Is what? Means that the chloride will combine with the Pb2 plus to form another salt, right? Because now you are doing like mixing together, okay? Then you actually form another salt, okay? But then what is the other salt? So if you think about it, Pb2 plus, Cl minus, you form Pb, Cl2. Kind of. So this is the new salt that you form inside here. Then they ask you what is the observation. They're not asking you what is the salt form. They're asking you what is the observation. So where you see before PbCl2, if you go back up again to your salt, if you remember, do you remember PbCl2 is actually white, but is insoluble in cold water, soluble in hot water. That's why I said that this chapter, right, very tricky is you need to recall your memory from different part. So if you say PbCl2, something I see, I remember this before. Jump here and there, correct? Because this whole chapter is like a library. Okay, whatever information your exam asks you, you must go like find the specific part that is related. Okay. So you see, hard or okay. So it means answer here supposed to be, yeah. You're supposed to see a white precipitate, and then this white precipitate is soluble in hot water, insoluble in cold water. So you see, white precipitate form, the precipitate will dissolve when heated and reappear when cool. Lacto chloride is formed. Okay, so that will be the explanation. Okay, moving on. How to remove ion in A in drinking water. So means if your drinking water inside got Pb2 plus, how do you remove Pb2 plus? Actually, the hint is from C. Do you realize that after added sodium chloride, the Pb become PbCl2, and then it comes out as a white precipitate, right? So after he become white precipitate, then you can filter the salt away, no? That's what you're gonna do. Add sodium chloride, filter out the precipitate. Then you remove Pb2 plus. Okay. So answer here, add sodium chloride into the drinking water, white precipitate form, which is lactochloride, can be filtered out. Okay, you'll try write this. Okay, moving on. Let's see. Let me look for the question. Okay, after the test like this, right? Maybe I will link to more on your salt preparation. Okay, let's see on salt preparation. Let me check my page number. Salt preparation on okay, page number 34, question number 17. Okay, page number 34. Okay, so this one here they say it shows you two experiments on the preparation of sodium chloride and copper 2 sulfate. So actually from here what we see is actually one is the soluble spar salt and soluble non-spar salt. How you know? Do you see the titration method? Soluble spar. Do you see the adding powder method? Soluble non-spar. Okay. So they ask you some question here. What is the reaction that takes place in one? Guys, I just mentioned, what do you call this? What is the reaction in one? If you all go and say titration, wrong. Because titration is the method. This one is supposed to call neutralization reaction. So reaction name is neutralization. Cannot write titration. So answer here is neutralization. Okay, so please be careful on this. If exam asks you method name, then you have to write titration method. But if exam asks you write reaction name, then you have to write neutralization. Okay, then state one observation. So what do you see, guys? When you actually add like hydrochloric acid to your sodium hydroxide with a phenolphthalein, so what you're supposed to observe when you do this experiment? You drip acid into alkali. When you observe the color, right? So it's supposed to have a color change. So what color change to what color? So we know phenolphthalein inside alkaline initially supposed to be pink. Then when you drip, become neutral, turn colorless. So answer here is supposed to be color of solution changes from pink to colorless. Okay, and then moving on, the other one is hydrochloric acid in experiment 1 is replaced with sulfuric acid of the same concentration. Predict the volume of sulfuric acid required for a complete reaction. So see, reaction 1, you realize that you use 40 cm³ of hydrochloric acid to neutralize 40 cm³ of sodium hydroxide. So it's like a 1-to-1 ratio. But if you change your hydrochloric acid to sulfuric acid, do you think you're going to use the same amount or different amount? If it's a different amount, is it more? Do you need more acid? Do you need more sulfuric acid or lesser sulfuric acid to neutralize the same amount of sodium hydroxide? Think about it. So how do you define? So if you try to recall hydrochloric acid and sulfuric acid, one is HCl, which is what we call it monoprotic. The other one is diprotic. So usually diprotic supposed to have double H plus compared to the monoprotic acid. So means if you change from monoprotic to diprotic, the number of H plus actually double up. So you don't need that much of acid anymore. So you reduce your amount of acid needed by double also, by half of it. Okay. So imagine like 40 cm³ of hydrochloric acid give you like 40 H plus. Okay, something like this a ratio. But then to get you 40 H plus, we only need 20 of H2SO4. Why? Because every H2SO4 got 2 H plus. So my answer here supposed to be 20 cm³. So you reduce your acid needed by half. Okay, and then on experiment 2, why we add excess copper 2 oxide? So what is the copper 2 oxide? It's the powder. So I actually mentioned just now why we put powder until excess. So because if you don't put until excess, can you react all your acid? No. If your acid not all reacted, then your salt producer got salt and acid mixed together. I don't want that. I want to make sure all my acid completely reacted. So to ensure all sulfuric acid is react completely. So this one to ensure. Okay, write the chemical equation. So it's actually copper 2 oxide, supposed to be CuO. Okay, copper 2 oxide CuO plus sulfuric acid is H2SO4. So H2SO4. So guys, come, give me the product form. So when you actually realize that there are like 4 ions inside all the chemical, right? So you can do what? You can exchange your girlfriend, exchange your partner. So you can do like Cu combined with SO4 becomes CuSO4, and then the H and O become H2O. So the good thing is, right, you realize it's already balanced. I just remembered need to memorize the most basic thing in chemistry. Ion charge. Make sure memorize that, Because why? Because the reason why it's CuSO4, because it's Cu2 plus and SO4 2 minus. And then what H2O? Because H is plus, O is 2 minus. So exchange, you get H2O. Okay. Ions, very basic, No, then very hard, Okay, Amin wishes to repeat experiment 2 by replacing copper 2 oxide powder with copper powder. In your opinion, do Amin make a correct decision? Explain your answer. So do you think like Amin is actually doing the correct thing? I take copper oxide away, I put copper. So if you think about it, okay, now it's copper plus H2SO4. You're going to be like, oh, can CuSO4 and then H2. So this one might sound correct, might sound legit, but if you remember, can copper displace H? Cannot. So this one actually cannot happen. Okay. Then what? Then why copper oxide can? Because copper oxide is not a displacement. Copper oxide is like exchanging partners. So exchange partner don't care reactivity one. Only displacement care about reactivity. So that's why from here you say you have to say no, and then you say copper metal does not react with acid. I miss Amin's burger. Hey, Jared, you come from the generation where Amin is actually making burger. Since you're from one class. Oh, yeah. How long have you been working at TDC? I forgot. Not don't recall when's the year that he actually he's still there. I mean, like he's still there lah, but then he don't sell burger anymore. I don't know. I forgot when was the year that he actually stopped selling burger completely. Last time he's like part-time at TTC and then part-time at selling burger So morning he work at TTC and then night he go and sell burger. 2021 he stopped. Is it? 2021 he stopped. Oh, so means like after COVID no more. Oh, okay. Wow, you remember very clearly, yeah? Not bad. Okay, so this one is soft preparation, Okay, I do one more question. Next page. Okay, so again got 2 tests. Okay, one is your sulfuric acid plus potassium hydroxide. Again, neutralization, But then test 2, okay, reaction 2, is bigger solution add into another bigger solution, and then you form a salt that is actually like a black sheet. Okay, like a black precipitate. I mean, it's not necessarily black, maybe it's just a no color ma, okay. So what happened here is, if you remember, test 2 is no longer, it's not the soluble salt anymore. Test 2 is producing an insoluble salt. So insoluble salt test, how to actually produce, we're going to use double decomposition reaction or the precipitation method. Remember that? Okay, so they say base in experiment 1, they want to write chemical equation. So actually, we can still do the same thing. It's actually sulfuric acid. So sulfuric acid is H2SO4 plus potassium hydroxide. Guys, what's potassium hydroxide? Potassium is K. Hydroxide is OH. So it's KOH. Then what you're going to do? Same thing lah. Exchange partner. Okay, exchange partners. Okay, correct. So if you actually exchange partner, you will get K2SO4. Okay, why K2? Because K plus SO4 is 2 minus. So K2SO4, and then with H2O. But this one, no, you have to balance equation. So K2SO4, 2H2O. Okay, don't forget the balance equation. Okay, then name the product formed in the conical flask. So conical flask is the salt you produce lah. So we call this the potassium sulfate solution and water. Okay, once this is okay, moving on. State another example of salt that can be prepared through this method. So guys, this method must be what method? Okay, I mean like to prepare what salt is to produce a soluble spar. So any salt that is soluble with sodium, potassium, ammonium. So got multiple answers lah. So we can say like sodium chloride. Okay, potassium nitrate. Okay, a lot of answers that you can put. Okay, so this one here is just like so test your understanding to make sure that you know actually what is the method to produce. As long as you know it is a soluble spar, then it works. Okay. So guys, moving down. Okay, based on experiment 2. Name the reaction. Guys, should I say precipitation or double decomposition? That's actually very, very important because they want the name of the reaction. So we're supposed to say double decomposition reaction. And then they say name salt T. So what is salt T? So you're going to actually try to construct the equation. So it's copper 2 chloride, CuCl2 plus sodium carbonate. So it's Na2CO3. So exchange partner. Cu CO3 with NaCl. And then balance equation like this. But then who do you think is the salt? The one that is insoluble. Because if you come out as a solid, then this I want this salt. This is a salt that is insoluble. That because come out as solid must be insoluble. If it's soluble, then it will not be a solid. So which one is insoluble? Which one is soluble? So according to what we know, carbonate insoluble. So we know the name. This one here is supposed to be called copper 2 carbonate, the CuCO3. Okay, after this testing, and now test salt preparation. Okay, let me do some heating questions. Okay, so if you guys are done, please go to question number 21, which is page number 38. Question 21, guys, it's on page number 38. Okay, so on this, so we got reaction 1, and then we heat compound X. Right? This is something that you're gonna actually again analyze lah. I heat X, and then I have a gas that turns lime water. They never say lime water. Okay, but later they say. Then for the second test, you see that heating of the compound. Okay, for here you see like you have test with moist blue litmus paper, and then you test with glowing wooden splinter. Okay, and then it gives you a brown gas, okay, and colorless gas cube, okay. And then they say heating of the compounds produces yellow solid when hot, white solid when cold. Guys, okay, they're supposed to have the same cation. So same cation means like X and Y, they have the same positive ion. And then actually yellow when hot, white when cold, it's supposed to be deciding one of your chemical already. So what is the chemical that is yellow when hot, white when cold? So yellow and hot, white when cold, yellow and white actually is your zebra. But then not just Zn, supposed to be ZnO. So means after heat already, you form ZnO. You get it? So that means your X confirm got Zn2 plus, your Y also got Zn2 plus. This one we know already. But then this one only decides your positive ion. They both have different negative ion. For example, they say that it will turn your lime water chalky, turns your lime water milky. Obviously, this one is when you test with like lime water. Obviously, you test with like you are testing for who? You're testing for carbon dioxide. So if you test for carbon dioxide, it means that your ion comes from carbonate ion. So it's like you see, like it's like a backward analysis because of testing CO2. Because got CO2, then we know come from CO3. You know got positive, negative ion CO3. Then same thing goes for substance Y. Because you after you heat got colorless gas Q and then brown gas R. So what is the negative ion? After you heat got two gas and then one of it is brown gas. So we know that the brown gas confirm is NO2. And then who is the gas that always come out together with NO2? Is your O2. All this is from where? So if you refer back to your notes, all this is from a heating test. And heating test is this one. You see, I heat carbonate, got carbon dioxide. I heat nitrate, got NO2 and O2. Now they ask you terbalik. They tell you got CO2, they tell you got NO2, O2, You have to know, I know got this negative ion, I know got this negative ion. So you are getting the result, use that result to predict your negative ion. Okay, so that's why on this case here, okay, where's my page? Page number 38. Okay, so from here, I kind of know that this one actually got CO3 2 minus, this one got NO3 minus because of the gases I get after heating. Okay, so write the chemical formula for X and Y, and then name PQR, suggest the reactant to produce X, and write a chemical equation for reaction 2, 9 marks. Sounds very easy to score, right? So what is the chemical formula for X and Y? So we know that X, Y, okay, X is what? Is Zn2 plus CO3 2 minus. So combine them. You're supposed to get Zn, CO3, and now Y is Zn2 plus and NO3 minus. So it's Zn, NO3 bracket 2. 2 mark. Okay. And then name gas PQR. So we know that PQR. So P is colorless gas P that turns lime water milky. So supposed to be, they want a name, so carbon dioxide. So cannot write symbol, they want name. And then Q is the gas that come out together with the brown gas. Okay, we know brown gas confirmed is who? Nitrogen dioxide. Then the partner of NO2 always is oxygen. See? Another 3 mark. Okay. I don't know why, but you can always say use back X and Y in equation, but maybe it's different type of question. Or you mean X and Y for your equation? For here, since you decide already, then you have to write according to the name, according to the symbol. You use back X and Y unless they never tell you what is X and they never ask you to find what is X. Means you leave X as unknown when the question never mentioned anything. But because right here you're supposed to like analyze and find out what is X and what is Y, right? Then you need to actually use the actual symbol of it. Okay. So you keep it as unknown if the question never say anything. If the question never asks you to find, if the question never tell you what is X and Y, then use X and Y. But here they ask you to find any, they ask you to define all these things. Then you can use back the actual symbol. Okay. And then after getting the 5 marks, right? Okay, they say suggest reactant to produce X. So X is the NCO3. So you want to produce a salt, means you're supposed to use your salt preparation knowledge. Okay. So if I want to produce the NCO3, I'm gonna use soluble spar, soluble non-spar, or insoluble salt. So if you think about it, X is the NCO3. Is it a soluble or insoluble salt? So I mentioned whenever you see CO3, most likely is insoluble, unless the partner in front of is spar salt. So Zn is not spar. So this guy here, this X is actually still your insoluble salt. So if it's still your insoluble salt, we're going to use the insoluble salt method. So what is the insoluble salt method? What's the insoluble salt rules? So we know that this guy here is insoluble salt. Okay, we're going to use the insoluble salt rules. Okay, so what is the chemical to produce the NCO3? I'm going to split the NCO3 into 2 chemicals first. So one of it must have Zn, the other one of it must have CO3. But the rules is what? To produce insoluble salt, the rules is soluble salt plus soluble salt, only you get your insoluble salt. You get it? So how to make sure Zn is soluble, CO3 is soluble? I add my spun salt. Okay. Spun I will use in my zinc. Why? Because it's NO3 minus. Okay. NO3 minus. Then I will use maybe sodium in my CO3 because I will get Na2CO3. You can also use K2CO3, up to you. So in this way, you can exchange your ions. You'll get ZnCO3 and NaNO3, which is this is a soluble salt. What we're focusing is this. So they say suggest the reactant to produce the NCO3. My answer is zinc nitrate solution and sodium carbonate solution. Okay. So until here you get like 1, 2, 3, 4, 5, 6, 7. You get 7 marks already because this one, this one 2 mark, this one 3 mark, this one 2 mark. Okay, 7 mark already. So still got 2 more mark. Is the last chemical equation for reaction 2. So what is reaction 2? The zinc nitrate being heated. So zinc nitrate is what? ZnNO3 Heated means you no need to pass anything, straight away just arrow, because heated just break up, decompose. So once it will decompose, you will turn into the yellow and hot, white and cold solid, which is ZnO. And then the two gas that you produced just now, NO2 and O2. See, actually they give it out the answer here, okay? But then you're gonna actually try to actually recall this. Okay, go according to what they actually produce. So you get NO2 and O2. Okay, but don't forget the balance equation because to get 2 marks here, you need to write out the equation. Second mark is the balance equation. Okay, so your balance equation, if not mistaken, you're supposed to get 2, 2, 4. Okay, let me check. So it's 4n, 2 Zn, 2 Zn, 12O. Yes, so this is supposed to be balanced. So 2 marks. Teacher, rate of reaction graph got what tangent? What do you mean got what tangent? You draw tangent line to find instantaneous rate of reaction. Tangent line is for you to get like the x1, y1, and then x2, y2, for you to do gradient formula. The y2 minus y1 over x2 minus x1, use that to find the gradient of a specific point. Usually they want you to find like rate of reaction at 1 minute, rate of reaction at 30 seconds. Then you have to draw the tangent line. Because calculation for rate of reaction got supposed to have 2 types. One is called average rate of reaction. The other one is called instantaneous rate of reaction. So average rate of reaction is like from 0 second to 30 seconds. There's a range of it so that one no need to draw tangent. That one just take the 2 points, okay, and then you can find gradient. But then for tangent line is because when you want to find rate of reaction at 1 point, 1 point cannot do gradient formula. So you have to draw tangent line on that point. So you get 2 coordinates. So then that 2 coordinate, you can use your tangent, your gradient formula again. Okay. Holiday school teacher just fit one did not focus on chapter 7. Okay. Guys, still got one more bit of time. Let me do one last question with you guys. Go for next page. Okay, now they say solid P is a carbonate salt. Okay, so carbonate salt actually give you a very big hint already. It means that inside confirm got CO3 2 minus. Then of course the positive ion, I don't know. The positive ion is something is unknown right now. But at least I know the negative ion. Then they say Q or they say P is a white solid okay, something carbonate. But then after they say it's turned into like solid Q, and solid Q is brown when hot, yellow when cold. So what is brown when hot, yellow when cold? So brown when hot, yellow when cold, it's your peanut. So peanut is what? PbO. And then in gas R, no information. Then plus acid, you get colorless solution. Okay. So now they say when P is heated strongly, it decomposes into Q and R. It means we know that this one's supposed to be a heating decomposition. Okay. Identify PQR. So what we know from here, guys, since we know after heating, you get PBO, it means that P, solid P, also got PB. You get it? If not, how are you gonna get PBO at the back? Teacher, how I said maybe solid P is MgCO3? Cannot be, because if I hit MgCO3, I will get MgO. Then that one is not your brown and hot, yellow and cold. You get it? So you reverse analysis. Because of the presence of PBO, I know my P also got PB2 plus. So it means from here, you guys, your P confirm got PB2 plus. So what is P? P is actually your PbCO3. Then if I hit carbonic, I always have carbon dioxide gas. So PQR 3 marks, you see. P led to carbonate. Q led to oxide. R carbon dioxide. Okay. Okay, moving on. Solid Q reacts with nitric acid to produce colorless solution T. Name the solution T and describe the test to verify the presence of cation and the anion in solution T. So since we know like this is already PBO, okay, let's try to bring the equation up. The equation will be PBO plus nitric acid HNO3. Okay, guys, what do you think you're going to form? Exchange partner. You can form PB and O3 bracket 2 with H2O. So now you know this is the product you're going to get. We call this the lead-2 nitrate, which is a colorless solution T. So the T is supposed to be this. Okay, name T. I just give you the name, lead-2 nitrate. But then they want you to describe the test to test lead-2 and the anion. So how do we test lead-2? How do we test PB2 plus? So if you again go back to our notes in the front, to test PB2 plus, how? Okay, to test PB2 plus, you go all the way back. Remember PB2 plus, we can test with potassium iodide to get you yellow precipitate. Okay, now. Okay, to test PB2 plus actually got a very special test. At Ki, you see yellow precipitate. Then how to test nitrate? You go back to the negative ion test. You see, nitrate test, how to test? At these 3 chemical, you see brown ring. That's why this question worth 7 marks. That is the reason why it's worth 7 marks, because you need to write 2 tests. One is the PB2 plus test, yellow precipitate. One is the nitrate test, the brown ring test. So the answer here, you see guys, you see my answer here? I will have lead-2 nitrate. This is 1 mark from what we mentioned just now, 1 mark. Okay. Then the cation test is I add potassium iodide. I will see yellow precipitate. So this one is 2 mark. So you see until here only 3 mark. So what's the last 4 mark? Is your anion test. So we will add dilute sulfuric acid, iron 2 sulfate, shake well, add few drops of concentrated sulfuric acid, slowly down the wall of slanted test tube. Guys, this is important. You cannot drip directly on the liquid itself. You must drip on the wall and then let it flow down. Then you will see brown ring. This one gives you 4 marks. Okay, so in total 7 marks. You see how it works, Guys. Now you know it's not easy to score in short chapter, So we're doing this in seminar because we don't have time in normal class to revise this anymore. Okay, so seminar hopefully can help you guys on chapter 7, 6 in your form 4. Okay, so guys, I covered few topics today. I trained you guys on how to use the notes already. So got color of salt, solubility of salt, preparation of salt, gas test, anion test, cation test. You see all test. So a lot of things will come out in one question. That's why I say, like, of course, one question not gonna ask you everything, but as I said just now, it's like a library. Okay, you see this information, you're supposed to relate to what color, what observation, what solubility. So that's why you need to know like all of the things just to solve maybe one simple question. Because you have to recall link to different information. Can guys? So I know, okay, short chapter is very boring, it's very tedious, it's very hard, okay. So you cannot skip lah. Teacher, can test 2 skip solution? What do you mean skip solution? Test 2 skip solution is what? In the testing solution. Like what? What do you mean skip solution? Skip testing solution. The sodium hydroxide? Okay, like skip the first NaOH, skip like the second one, and then straight away go for Ki. Oh, can. Ah, can. Like usually the usual way is step 1, step 2, step 3 ma. But sometimes if you want like a specific observation, you can straight away go for the test. Like you see yellow precipitate only appears in Ki ma. So Ki can be one test itself. Okay. You get it? Can skip one. Some of the tests inside the table can be their own individual tests. It's not necessary to like confirm step 1, step 2, step 3 like that. No. Can skip one. Okay. Can so guys, I'm glad, okay, even with just 5 of you guys still stay through the whole class lah. So thanks for coming to a Sunday seminar. Hopefully you guys can learn better inside here. So of course guys, this video we posted into YouTube. Go to YouTube and search for this video, and then you will see, you can watch it anytime you want lah. Okay. So guys, the rest do yourself refer to answer if you don't understand. If you cannot actually find the answer, you don't answer also can come back to me lah. Okay. So guys, okay, finally understand after so long. Oh, I'm glad that I actually helped. Okay. So that is if I'm subscribed. I mean, you don't have to subscribe, also can search on ma. Okay, you just go to YouTube, search for TTT education. Don't need subscribe, also can one. Just go inside whenever you want to actually watch the videos lah. No need subscribe, it's okay one. Okay. So guys, thanks for coming. I'll see you all in next week class. Okay. Thank you guys. Bye bye.